Hi, my name is Sima Suthar, and today I represent the STT500, and our group is Group 5. And there are Group 4 members like me, Sima Suthar, and then Ujma Patel, Rajinder Kaur, and Gurkirat Kaur. So, my presentation is about statistical case scenario analysis. So, first of all, I would like to start with data set that is about categorical variables, numerical variable, graphical presentation, and hypothesis regression analysis. So, in numerical variable, that is about math score, reading score, and writing score. So, in the math score, the distribution of math score appears to be roughly systematic with a slight left skew. Most students scored between 40 and 80 with a few outline at higher scores. And, and also we can also see reading score. In this reading score, we can see the distribution of reading score is more evenly distributed compared to math score. Most students scored between 50 and 80 with fewer outliners. And also we can also see in writing score, similar to the other reading scores, the distribution of writing scores is also relatively balanced. Most scores fell between 55 and 80. So with fewer outline at higher scores. And I also talk about categorical variables, and that is about gender, race, and ethnicity, parental level of education, lunch, and test preparation course. So in gender, there are more female students in the data set compared to the males, and also in race and ethnicity. The majority of students belong to group B, C, and D, while group A and E have fewer students. Parental level of education, the data set consists of students with parents having various level of education, including some high school and also associate degree, bachelor's degree, and master's degree. The most common level of education is some college. And also in lunch, the majority of students have a standard lunch, while a smaller proportion of students receive free lunch. And also in test preparation course, most students did not complete the test preparation course, while a significant number of students completed this course. So I also talk about key findings. In these key findings, there is no strong correlation between gender and test scores. Both male and female students have a similar range of score, and students from different race and ethnicity groups have varying performance levels, and also parents and education levels to have a positive impact of student score. Students whose parents have higher education level, taste, and higher scores, although other factors also may play in this role. And also, so overall, the data set shows a wide range of score across all subjects, including that factors other than the variable provides the data set may also contribute to students' academic performance. And also, I'm also talking about variables and graphical presentation and hypothesis. And also in hypothesis, test using two sample test. We need to formulate the null and alternative hypothesis. In null hypothesis, there is no significant difference in the mean math scores between male students group A and the female students group B. And alternative hypothesis, there is a significant difference between math score and between male students and female students like group A and group B. And also statistical decision, we will use a significant level like alpha of 5%, 0.05 for our hypothesis test. So the specific group being compared and the choice of variables can be modified based on the specific analysis and research question. So now next slide by Ujma.
Hello, I am Ujima Patel. Now I am start about evaluation of performance simple linear regression. To evaluate the performance of simple linear regression analysis, we need to select two numerical variables and analyze their relationship. In this case, let's consider the math score as the dependent variable and the writing score as the independent variable. We will assess the suitability of using the writing score to predict the math score. Here is a process of variable selection and justification like a data exploration, scatter plot, correlation analysis, a regression analysis, interpretation of regression result, residue analysis, and model validation. Next topic is evaluation of performance multiple linear regressions. To evaluate the performance of multiple linear regression analysis based on the three numerical variables, namely math score, reading score, and writing score, we can follow these steps like a variable selections. Firstly, if we need to access the correlation between the variable to identify the potential predictor, we can evaluate the correlation coefficient between each pair of number variable. Second one is a regression data analysis. Once we have selected the variable, we can perform a multiple linear regression analysis using software or statistical tools, the dependent variable and independent variable. Third one is a evaluate result. Next slide, please. Now I am discussing about model assumption and common violation. First one is a model assumption for the simple linear regression model and common violations. To check the model assumption for the simple linear regression model, you need to have a numerical independent variable and numerical dependent variable from the data set you provide. We can use the math score as the independent variable and any of the reading score of writing score as the dependent variable. That assume we using reading score to the dependable variable like assumption, linearity, independence of error, homoscedasticity, normality of residue, independence of observation. And here common violation lies a non-linearity, heterogeneity, and non-normality of residue. Second one is a model assumption for the multiple linear regression model and common violations. Here, to check the model assumption for the multiple linear regression model, and you need to access the following assumption and potential violation like a linearity. The relation between the independent variable and the dependent variable should be linear. Independence, the observation should be independent of each other. Violation of independent can occur when there is a autocorrelation. Third one is a homoscedasticity. The reschedule should have a consonant variation across different level of independent variable. Fourth one is a normality, and last one is a non-multipolarity. And there here is a common violation like a non-linearity, heteroscedasticity, and normality. Now continue by Rajinder.
Hello, my name is Rajinder Kaur. We have discussed about the Model 1 versus Model 2. To evaluate the performance of the simple linear regression Model 1 and the multiple linear regression Model 2, you can compare several metrics and diagnosis. Model 1 is simple linear regression. In Model 1, you would select one independent variable, for example, math score, to predict the dependent variable, for example, reading score. In Model 2, multiple linear regression. In Model 2, you would include multiple independent variables, for example, math score and writing score, to predict the dependable variable, for example, reading score. To compare the performance of these models, you can consider the following metrics. First one is R square, second one is adjusted R square, third one is F statics, fourth one is residual analysis, and fifth one is standard error of the estimate. Next one is at the 0.5 level of significance, determine whether the independent variable make a significant contribute to the simple linear regression model 1. In model 1, to determine whether the independent variable make a significant contribute to the simple linear regression model 1. You can perform a hypothesis test using the coefficient of the independent variable and its associated p-value. Here, how you can proceed. Step 1 is state the null hypothesis HO and the alternative hypothesis H1. Step 2 is set the significant level to 0.05. This determines the threshold between which the p-value must be in order to reject the null hypothesis. Step 3 is perform the hypothesis test. Step 4 is interrupt the results. And next one is model 2 to determine whether the independent variables make a significant contribute to the multiple linear regression model 2. You can perform a hypothesis test using the coefficient of the independent variable and their associated p-values. Here's how you can proceed. Step 1 is state the null hypothesis HO and the alternative hypothesis H1. Step 2 is set the significant level to 0.05. This determines the threshold below which the p-values must be in order to reject the null hypothesis. Step 3 is perform the hypothesis test. Step 4 is interrupt the results. Now we can discuss next slide is Gurkirat Kaur.
Hi, I'm Gurkirat Kaur. My student ID is 201737332. I'm explaining the conclusion. It's variables. The distribution of math scores is roughly symmetric with the slight left skew. The distribution of reading scores is more evenly distributed compared to math scores. The distribution of writing score is also relatively balanced. Most scores fall between 55 and 80, with fewer outliers are at higher scores. Sample test. The null hypothesis states that there is no significant difference in the mean math scores between male and female students. The alternative hypothesis students suggest that there is significant difference in the mean math scores between male and female students. Sample linear regressive analysis. To evaluate the performance of simple linear regressive analysis, we select two numerical variables, for example, math score and writing score, and assess their relationships. Next screen, please. Multiple linear regressive analysis. To evaluate the performance of multiple linear regressive analysis, we consider three numerical variables, for example, math score, reading score, and writing score. Variable selection is based on correlation analysis, relevance to the problem, and interpretability. Performance evaluations of regressive models. To compare the performance of simple linear regressive model 1 and multiple linear regressive is model 2. Metrics such as R-squared, adjusted R-squared, F statistics, and residue analysis can be considered. Thank you.